সো এখন আমরা একটু মাল্টি থ্রেডিং নিয়ে অল্প কিছু পড়াশোনা করব। সো প্রথমেই আমরা শুরু করি। আমরা প্রথমে কোডটা এক্সপ্লেইন করব অ্যান্ড অ্যাট দ্য সেম টাইম আমরা এটা বিল্ড করতে থাকবো। আই থিঙ্ক এতে করে আমাদের কনসেপ্টটাও ক্লিয়ার হবে যে কোন জিনিসটা কোথায় কাজে লাগতেছে অ্যান্ড হোয়াটস বেসিক্যালি রিকোয়ার্ড, অ্যান্ড আমরা অ্যাট দ্য সেম টাইম প্র্যাকটিস করতে করতে যাব। ওকে, সো স্টার্টেড। ফার্স্ট অফ অল এখানে একটা ক্লাস এ আছে, দ্যাট ইজ ইমপ্লিমেন্টিং রানেবল। দ্যাট মিনস মাল্টি থ্রেডিংয়ের একটা ওয়ে রানেবলকে ইমপ্লিমেন্ট করা। রানেবল ইজ এ বেসিক্যালি ইন্টারফেস, এটা একটা ফাংশনাল ইন্টারফেস, কারণ এটার একটা মেথডই আছে, মানে এই ইন্টারফেসটার, সেটা রান মেথড, দ্যাট ইজ পাবলিক ভয়েড রান। এটাকে যদি আমরা ওভাররাইড করি, দেন এইটার একটা ইনস্ট্যান্স ক্রিয়েট করে, মানে ক্লাস এর ফর এক্সাম্পল একটা ইনস্ট্যান্স ক্রিয়েট করে দেন আমরা যদি স্টার্ট দিয়ে দিই, স্টার্ট মেথড আছে। সো দেন আমাদের এই রানের ভেতরে, মানে রান মেথডটা থেকে এক্সিকিউশন স্টার্ট হবে। মানে এখান থেকে যদি নেক্সট আর কোনো মেথড যদি বেসিক্যালি কল করা হয়, দেন ওগুলো কল হবে। ওকে, আমরা এখন তাহলে দেখতেছি যে এখানে একটা ক্লাস এ আছে, দ্যাট ইজ ইমপ্লিমেন্টিং রানেবল অ্যান্ড পাবলিক ভয়েড রান। এখানে আমরা এ থ্রেড ইউজিং রানেবল, দ্যাট মিনস রান মেথডটাকে যদি কল করা হয় বা যদি রান মেথডটা কল হয় সামহাও, দেন আমরা এই অপারেশনগুলো এখানে চালাবো। সো স্টার্টেড। সো উই ফার্স্ট নিড এ ক্লাস। সরি, আগে আমি একটু সেভ করে নেব। I have done it 2 times, so I think it's the third time, so that code 2, 1 code 2, okay. This will be left 13. Okay, now subject class left 13, public static void name string increments. Alright, now first of all the class A that is implementing implements runnable. Runnable is an interface, functional interface, and we will override public void run that has no parameter. So first of all we're printing that we'll be implementing a thread, right? So we'll be creating a thread for using this A class. So we can say that A thread using runnable. Alright, now we try to sleep the thread, I mean the current thread. So thread dot sleep for let's say 500 millisecond, and then we try to we are trying that, and so we have to catch exception. The only exception can be occurred here is basically interrupted exception E, and we try to if there is an occurrence of exception, this particular exception, that is interrupted exception, then we try to print stack trace, I mean the reason for that, and continue on. Now once we are done with the operation, so we say that A thread ended, alright, or end of the A thread, so A thread end. So that's basically it. Now there is another method, so another way to actually implement this model of multi-threading in Java, that is basically extending the thread class itself. So there is basically some difference here. For example, whenever we try to implement the multi-threading feature for Java, one way is implementing the runnable interface, functional interface, and another way is basically extending the thread class. Now extending the thread class is somewhat, the thread class have a lot of different functionality, that means method, and also it has some enumeration, so constant values, not enumeration, constant values. So that's why whenever we're trying to extending a class, thread class, we are inheriting all the methods. So if I don't require all these methods for a particular job, for example, then we will try to stick to our basic rule that we'll just implement the runnable. And then here, for example, if I want to create a thread, new thread, for example, so thread T, for example. So let's say that is our new thread and sending or passing an instance of this class that is implementing runnable. So this is a way to do this. So for example, t.start will call the run method in the class A. Now if we try to Java C lab13, Java lab13. So a thread using runnable and then 500 millisecond of break, that is sleeping, and a thread end. Alright, so that's the way. And also another way I told about it, that class B that extends thread itself. Example, it also override where's the public void run. So we're saying something like B thread using extend. Alright, so B thread using extend, that also followable. Now we try to get sleep, so 500 millisecond, and then try to catch it, interrupted exception, and trace. And now B thread ended, and alright, so that's another way. Now if we try to thread D1 is new, at this time we don't need to create the instance of we don't need to create the thread like new thread and then passing an instance of that class. Basically it's extending the thread class, so we are able to have the reference even in this class particularly. So bt1 new b, and that will definitely work. For example, t1.stir will give us something like, the two particular child thread is running at the same time. So it's really great, I think, that we're basically having something like that. Two particular method is running at the same time. Whenever we're starting that particular a thread using runnable, and then the thread goes to sleep for 500 millisecond, and at the same time it is basically running the b thread that is using extend, and then it also goes to sleep, and then other thread after sleeping for 500 millisecond, it basically awakens and then finishes its basically execution. So that's really interesting that we are not wasting our CPU time. So we are actually utilizing the actual computational power of CPU. So we are not wasting the lazy time of CPU. So that's why it's basically important to implement the multi-threading model of Java language, for example. Now another way that we can create our child thread, that is using anonymous class. So we are basically we're basically having a class that is our anonymous class, and that is extending thread, and we're trying to override the run method of it, right? Public void run, and then we print something like that ano class using extend, for example. Okay, so let's say C thread, for example, alright, or new thread. Okay, so T2 thread using just anonymous class, and then try to thread sleep 500 millisecond and catch exception. We don't need to even handle this because usually that's not going to be the case here. So ano ended. All right. So that's another way. Now this is basically lambda expression, and that's why we'll have to end it using the semicolon. So we can also start this. Yeah, t2 thread using ano, and these are being finished. Okay, so that's the way. There is three way that we are creating the child thread. Now, how do we get a thread? For example, if we want to get the main thread, so we say something like main thread is thread dot current thread. So I guess it will give us the information related to main thread. As you can see, yeah, thread, and that is the number 1, and main having priority 5, and main is the group name maybe. So we can also say that main thread dot set name main thread, for example. Now once again, if we try to print the main thread reference, so we get the name changed, right? So yeah, the main thread, as you can see here, this is printing main thread. We can also set the priority here, I think. Sorry, main thread dot set priority to be thread dot, for example, max priority. So it's a constant value that will be having value 10, I think. Yeah, now it's 10. It's basically 10. So these are something that we can work around. Now to join all these, okay, so let's see what else we have. Yeah, anonymous thread, and then we can join all these. So try t dot join t1 dot join. So what this basically join doing here, join if there is any exception, that will be interrupted exception, and we don't even need to handle this, we're just catching it. So this join means that once we are done with the particular execution of that particular thread, then we can move forward. So for example, t1 dot join, that means the execution of t thread is done, and then we'll move forward to the next line, that is t1 dot join. So once we are done, that means all these particular thread are basically done in their execution. So now they're terminated, right? So they were created, they were ready to started to be started, and then we basically terminated that. These threads are basically terminated. Now can we start them again? Let's try to start it. For example, t dot start, then we'll be seeing something like that illegal thread state exception. That means the thread is basically has gone to the state of being terminated, and once a thread is terminated, it cannot be restarted, right? So that's basically the thing. So that's a way to think around it, so we cannot do this. All right, now is there anything else? No. So finally we'll have something like the main thread ended. After all this working on this thread may end, I think. Yeah, so that's basically it. Okay, so now I think we have some other works. we need to talk more about synchronization. Yeah, we can talk a little bit about synchronization as well. That's not so lengthy, I guess. Okay. Synchronization. So lab 13. There's the second code. Public class lab 13. To okay. So okay, one thing we missed previously, that is, our uh, uh, inside of our A class and B class, we could have static methods like create and start. For example, it will be creating an instance of itself, it will be creating a thread of itself, and then it will be basically starting itself, and will basically pass a reference to the thread so that we can use it further in the future. Okay, so that also possible. Let me just finish the synchronization part, and then we can move forward with the with that particular methods in those class. So here's a class and it's having a method. So it's a class, it's having a method. All right, now the method basically tries to print a message. Before that, it says that printing the message, and then it tries to sleep 2000 millisecond. All right, that means the thread that using the thread that is being used to call this method is being slept for 2000 millisecond, and after that, then it basically prints that message, and then printing is done. So what's the trick here? The trick here is that, for example, a thread, for example, T1, that is thread 1, is trying to call this particular method. So what it does is it printing the message on the console, and then tries to sleep for 2000 milliseconds. Now if another thread is basically calling the same method, so it will basically have that console for that moment if the method is not synchronized. So at that particular moment, it will also print something like printing the message. So and then whenever that 2000 millisecond is basically done, then one of the thread will print the message and then say printing done. But there is no guarantee that the first one that was going to sleep, that will be printing at first. So the console is not basically holding for the thread 1 to finish its particular method. So the full execution of this method is not being done in a compact way. But sometimes it's critical that we are printing the message and we don't know who is basically printing, thread 1 or thread 2. And if there is some information gap, that is thread 1 is basically manipulating something, and then thread 2 is printing that message before even printing thread 1, right? So there is some problem. That means we are using the same resource. For example, here the console that is printing the message, so it is being used simultaneously by thread 1 and thread 2, and there is some information gap, so we can be confused that who is doing what. So there are some problems, so we have to deal with that. So what's the solution for that is basically synchronization. So for example, here synchronizing the particular method will do the work, right? So that's another way. But at the same time, there is another way to synchronization, that is basically using synchronization block on a particular on a particular object. For example, this particular object A is having that non-static method, and we are trying to call that method from a synchronized block. So if we are calling it from 3 different places or 2 different places, uh, whenever we are calling it, so we are trying to we are trying to call it from a synchronized block. So so that's where the idea comes, that then we are trying to synchronize that particular object, so using the synchronization block. Now synchronization block is useful when, you know, the method can be extremely critical, but the part that is, you know, that the, for example, one particular part of the block or the method may be critical, or you know, something like using the same resource. So we need to just we just need to synchronize those particular critical points or stuff like that, and that's why we'll have to understand it, that we don't need to eventually synchronize the whole method, because the method can be uh, uh, as complex as, you know, very very much complex, and for that reason we'll have to synchronize that particular critical section, and that's where this synchronization block, the idea of synchronization block comes in. So that's why we'll have to understand it and we'll have to work on it. So let's try to do something around it. So we are having a class A, and it's having void a method message, and first of all it says that it's printing the message, and then tries to sleep for 2000 milliseconds, and we're trying to catch it, interrupted exception E, and then we're trying to say something like print the message, and then say that printing is done, alright. So that's the method. Now let's try to create a thread, for example, new thread, alright. But this thread, okay, we can do it with anonymous thread, for example. So it will public void run. So what this method will do is nothing but calling this particular method. For example, we have one object, right? So new a, so the object is common, that is a object, and we're trying to call this a.m with a message that message from thread 1, okay. So that's completely all right. So let's try to start the thread 1. For example, C lab 13.2 Java lab 13. There is some error. Yeah, we did not do semicolon. Let's forget it. Printing the message, and then 2000 milliseconds message from thread 1, and printing is done. Now we're trying to create another thread. Thread T2 will do something like new thread. So it will be implemented. So public void run. Now we again call from message from thread 2. So let's try to, oh sorry, so T2 dot start. Okay, so printing the message, and you know, first of all the second thread printed the message, and then the first thread. So we need to synchronize this. So one way for this is basically just making the method synchronized using the synchronized keyword. I guess it will work. So this way basically only one thread can enter into that particular object, that is the method, at the same time, so simultaneously. So for example, thread 1 has entered first of all into that particular method, so it will finish its execution. That means thread 1 will finish its execution, the method 1, and then thread 2 can basically come into that particular method or that particular object here. So that's where the idea of synchronization comes. So another way to do it, for example, 2000 milliseconds is basically a lot of time. Okay, no problem. 2000 milliseconds is not so big. So we can do it from a synchronized block. So synchronized and on what? A object. So from here we can say that we are calling that a.m. So message from thread 1. Okay, so let's say we're trying to synchronize only one particular block. So we're calling from this from particularly here. So let's say whether it serves our need or not. No, it does not. So that's the problem. So we need to synchronize both of the sections here. So we need a synchronized block, and from where we'll call something like message from thread 2. So that's completely alright, I guess. So as you can see now, the thing is completely synchronized. Alright, so that's an important thing, I guess. Okay, so now for example, if we wanted to create another thread, d3 is equals new thread. So anonymous class is being used for doing so. Public for run. Now synchronized. Okay. A.m. message from thread 3. So it will cost us around 23.start. Alright. So okay. Definitely works. Okay, no problem. So one by one. So first of all the first thread, and then third, and then 2. Okay, now let's try to not synchronize these particular thing, the last one. So we're just calling the message from thread 3. Now let's see what happens. Yeah, it's definitely not going to work as we thought about it. So I guess this is the thing that we are trying to do here. Yeah, that's it. I hope you understand the basic ideas of thread synchronization and multi-threading in general. So that's basically it. I hope you understand, and please let me know what you want to know about and whether I need to improve in my explanation strategy or not. Please let me know. So I will end up here today. Assalamu alaikum warahmatullahi wabarakatuh.